So let's see example on principle of mathematical induction. So now prove by principle of mathematical induction that 1 plus 2 plus 3 plus to n is equals to n plus 1 divided by 2. That is, sum of first n natural number is n plus 1 divided by 2, where n is a member of natural number. So remember the steps I said we are going to take to prove using mathematical induction. Now, step 1. Step 1. Show that the given statement is true for n is equals to 1. So that is step 1. Show that the given statement is true for n is equals to 1. So you are going to test the left hand side and also the right hand side. Now, for left hand side, the first number is 1. So that is for n equals to 1 means you are going to pick the first number. If it is for n is equals to 2, you are going to pick first number plus second number. That is 1 plus 2, 3. I've explained this in the introductory parts. So, but for mathematical induction, we test with the first number most of the time. Now, show that the given statement is true for n is equals to 1. So that means the first number is 1. So that is n equals 1, left hand side. Now, the right hand side. So right hand side, you have n plus 1 divided by 2. Now, put 1 anywhere you see n. So this will be 1 plus 1 divided by 2. So that is 1 bracket 2 divided by 2. So that is 1 because 2 will cancel out 2. So what do you observe here now? You can see that sum of the first number in left hand side is 1 and sum of the first number in the right hand side is also 1. So far we achieved this. So you will just say, therefore, the statement is true for n is equals to 1. So we have proof for step 1. That is, the statement is true for n is equals to 1. So you move to step 2. So step 2, you will write, assume that the given statement is true for n equals to k. So remember, all these steps are important in proving P.M.I, mathematical induction, principle of mathematical induction. So step 1, show that this given statement is true for n equals to 1. Step 2, assume that the given statement is true for n equals to k. So for n equals k, so I have 1 plus 2 plus 3 plus up to k. Remember, in the question you have 1 plus 2 plus 3 up to n. So but now I'm proving that it is true for n equals to k. So that will be 1 plus 2 plus 3 then plus k instead of plus n here. So I'll write plus k because I'm proving that it's true for n is equals to k. So which is equals to, here is n plus 1 over 2. Then it will be k plus 1 divided by 2. So for k is a member of natural number. So this second proof is the simplest because just assume n is equals to k, then you have this. So you just conclude the statement is true for n is equals to k. So now it remains step 3. So it's step 3 that usually take some kind of manipulation to achieve. So now step 1 and step 2 is very easy. So let's see step 3 now. So you can write it down. So step 3. So you write using the assumption made in step 2 show that the statements is true for n is equals to k plus 1. So step 1, you first show that the given statement is true for n equals to 1. Step 2, you will assume the statement is true for n equals to k. Then step 3, you will use the assumption made in step 2 to show that the statement is true for n equals to k plus 1. So now let's show for k plus 1. So I have from the equation now, so we have the right hand side. So 1 plus 2 plus 3 up to n. Now this n, I'm showing that it is equals to k plus 1. So that means I will have for right hand side now. So everything will be equals to left hand side. That will be 1 plus 2 plus 3 plus then plus k plus 1. So instead of plus n, so you write plus k plus 1. So instead of plus n here, so n is now k plus 1 because we want to show that it's equals to k plus 1. Now this is the left hand side. So we can also say this left hand side, that is all this, is equals to 1 plus 2 plus 3. So this is the step we'll be taking for the step 3. So instead of writing all this now, I can say it is 1 plus 2 plus 3 plus, so like this. So let me bracket this to see, plus k plus 1. So that means everything I write here is the same thing as what I have here. So just that I put brackets here, as in that's what we have there. So it's still the same. So that means this is 1 plus 2 plus 3 plus k plus 1. So it's equal to, so now if you look at all this, what I write now is just to repeat this, that is another step. So because my first step now is that all this is equals to this, and you see it's still the same. So now but look at the bracket here, you will notice it is incomplete That is, I have 1 plus 2 plus 3 plus is incomplete, so I have to complete it. That is 1 plus 2 plus 3 plus, then up to plus k, as in like that, then plus k plus 1. Remember, I have k plus 1 here. This is it. So, and all this one, I just complete it plus k, so that is it. Yeah. So now everything in this bracket now is like what you have in your question. In your question, you already have the sum of first n term, that is 1 plus 2 plus 3 plus n, is equals to n plus 1 divided by 2. So that means if this is k now, then this will be k plus 1 over 2. So look at it here now. So instead of 1 plus 2 plus 3 plus n, so I now have plus k. So that means my result is k plus 1 over 2. So that means this is equals to k plus 1 over 2. All this, that is the sum. Then I have plus k plus 1. Remember this one. So now this is equals to, you can actually find the LCM of this equation. So find the LCM. So if you find the LCM, or you factor out k plus 1, anyhow you do it. So if you remember, this is over 1, and if you look at it, instead of finding LCM, you can say k plus 1 is here, k plus 1 is here, meaning k plus 1 is common. So if you factor out k plus 1, so it will remain what? Yeah, it will remain k over 2 plus 1, because if you say k plus 1 is common, so that is what you will have. So k plus 1 will be outside the bracket. So now, what are you going to have next? So if you don't do it this way, you can find the LCM like I said. So I'm just trying to use different methods so that anyone that is convenient for you, you can use. If it is that it's k plus 1 you want to factor out, then you can factor it out. So let me finish the k plus 1 first. You see that k plus 1 is common. K plus 1 is here, is also here. Remove it out. So it will remain k over 2 here. So it remain k over 2 plus 1. Remember, k plus 1 is out. So this one is over 1. So what's the LCM in the bracket? So the LCM is, so that means this is equal to k plus 1. So LCM here in the brackets is 2. So that will be 2 into 1. So that will be 1 times k plus 1 into 2. 2 times 1, 2. So that's what I will have there. So now 1 plus 2 plus 3, then plus k plus 1 is equal to k plus 1 k plus 2 divided by 2. So that's what I will have here. That is k plus 1 times k plus 2. That is it up. Then do you know this is over 1? So 1 times 2, 2. That is the denominator. So like that. So this can also be so this is equals to, because our aim is to change everything in terms of k plus 1. So now how can you change k plus 2 now? Do you agree k plus 2 is k plus 1 plus 1, because 1 plus 1 is 2. So that is it. So now anywhere you see k plus 1, you can actually put n back. So anywhere you see k plus 1, you can put n back because you have achieved k plus 1 here. So now I'll say when n is equals to k plus 1, remember that is our third step. So we want to show, using the assumption made in step 2, that the statement is true for n is k plus 1. Now when n is k plus 1, so anywhere you see k plus 1 here, put n back in this last equation. So remember, this will becomes let me clear the so now I'll have 1 plus 2 plus 3 plus, instead of writing k plus 1 now, I'll write n. Remember, I'm the one that changed all this and solved to this stage, so that anywhere I see k plus 1, I'm replacing it back with n. So it's equal to k plus 1, that will be n, brackets, this is another k plus 1, that is n plus 1 divided by 2. Remember, this k plus 1 is n, so I have plus 1. So that means n plus 1 divided by 2. Now if you look at this result, now I have achieved this back, as in 1 plus 2 plus 3 plus n equals n plus 1 over 2. So if you have achieved this back, that means the statement is true for n is equals to k plus 1. So you now conclude, therefore the statement is true for n is equals to k plus 1. So now if n is now true for, as in the statement is true for n is k plus 1, as you can see here, then your final conclusion is now that hence by P.M.I, that is by principle of mathematical induction, 1 plus 2 plus 3 plus n is equals to n plus 1 divided by 2, for n is a member of natural number, is true. Proved. So that is it. So we'll see another example so you will understand better.